everybody. My name is Neha, and today I'm going to be talking about some of the challenges that I'm facing on one of the chapters of my PhD thesis, monitoring closely related rockfish using eDNA. So I'd just like to start all my talks with the reminder that our oceans are stressed and that our health and livelihoods here on the surface are intimately connected to that of the ocean. And a biodiverse ocean truly is a healthy ocean. So why are we talking about rockfish? Well, as I just said, the world is losing biodiversity at an unprecedented rate. In British Columbia, rockfish are one of the groups that have been declining over the past decades due to many different reasons. They're a really important group. They are culturally, economically, and ecologically important, and because of this, there's a lot of priority in monitoring these species. And mainly this has been done using long lining and scuba diving surveys. But, surprise, surprise, I use eDNA. So I'm using both targeted and metabarcoding methods to detect species of interest and to assess rockfish biodiversity. But working with a group this large is quite challenging. So rockfish worldwide, there's over 100 species within the genus. And in British Columbia alone, we have 38 species. In this photo, you can already see 3 of them. And this group is pretty new, and so there's a lot of high interspecific sequence conservation. So what we're looking at here, this is a region that probably many of you are familiar with. This is the MyFish region, or the 12S region of the mitochondrial genome. Each line is a different rockfish species, and the black lines denote differences. And so obviously, if we're trying to tell these species apart, this region is not going to work for that purpose. So our lab, the Helving Lab, in collaboration with the Barol Lab at the BC Genome Sciences Center, have developed a bioinformatics pipeline called UniqueSeq. Okay, and what this pipeline does is essentially it goes through the mitochondrial genome and finds areas that are unique or variable to your region. And so if we're working with a metabarcoding assay, we're looking for those variable areas. So you can see MyFish, we don't really have that within this group. The MySebastius assay was developed by a group in California, and you can see there's a little bit more variability. And I've developed another assay in the middle, and there's variability there as well. And you can see that reflected in these alignments. So these are different regions within the mitochondrial genome which have more variability. But with that said, I just want to say this group is so closely related that there's some that I just still can't tell apart. Another challenge is that not only is this group pretty closely conserved as a genus, but within individual species, there's a lot of intra-specific variability. Okay, so what you're looking at here, these are 3 different fish. These are identified as important by our collaborators. And each line here now shows a different individual of the same species. And what you can see is that there's still a lot of variability within the species itself. And so if we're trying to create a targeted assay for this species, oh my goodness.
It's probably slow changing slides.
Just wait on it?
It's trying to catch up now from multiple presses.
Okay. All right, well, I'll just stay here. Hopefully it doesn't move anymore. But what we can see is that that's going to be challenging if we're trying to create a targeted assay. Okay, so I'm going to focus on the bottom species here. This is the yellow-eye rockfish. It is listed as species at risk in Canada. And what you can see, so basically we had run reference sequence, we designed an assay, we're like, ooh, it looks pretty good in comparison to other rockfish. We deployed it in the field, and it didn't work. And it was only when we got sequence data back from some voucher specimens we sent for sequencing from the region we were working in, we realized why. There was a lot of variability in our key assay region. So we designed another assay with all of our new reference sequences, and it's working pretty well in the area that we're working in. But obviously with these patterns of high variability, we really need to think about, okay, is this assay going to continue to work as we expand geographically? So the takeaways that I want you to leave this talk with is that working with large, closely related genuses is very challenging with eDNA, and this is not just specific to rockfish, obviously. So that really enforces the importance of thinking about the questions we're asking to make sure that we're using appropriate methods. We also obviously need more sequence data, so not just more individuals to capture variation, but also focusing on large microgenome sequencing. So that's what the iTrack DNA project does. And that essentially gives us more real estate to work with. So then when we're working with challenging groups like this, we're not constrained to those commonly used barcodes. And finally, careful assay design is vital, especially if we want eDNA to be used for conservation and policy-making purposes. And so, okay, today I talked about challenges, but I have a bunch of cool data from this project that I love to talk about, so come talk to me if you want to learn more about rockfish. And with that, I would like to say thank you to all of my collaborators on this project, my lab, and also all of the people who have supported me. Thank you.